Example, a bartender asked a sample of his patrons how many drinks they consumed during the weekend on average. The findings are given in the table below. So when we count up all these numbers, we should get 24 total. Part A, we want to construct a frequency histogram for the data in the table. We're going to begin with a lower class limit of 9 and a class width of 2. So if we start with the lower class limit of 9, since that's our lowest number, that means that our class width is 2, so we're going to add 2 to get 11 for the next class, that's the lower class limit, and then 13, 15, 17, 19, and 21. And then over here, we're going to go from 9, it's going to start at 10, so this is 10, 12, 14, 16, 18, 20, and 22. So we can see here that the smallest number is 9, and the largest number looks like it's 21, so therefore we're going to go from 9 to 22. So that means we have 1, 2, 3, 4, 5, 6, 7 classes, which represents the number of drinks. Then we're going to represent the frequencies. So how many are between 9 and 10? We had 1. How many between 11 and 12? We have 3. How many number of drinks between 13 and 14? We had 5. 15 and 16 were 9. 17 and 18 was 4. 19 and 20 was 1. And 21 and 22 was 1. Now, if we want to construct a frequency histogram, then what can we do? Well, here we can start at 0. And we know that our frequency always has to be our vertical axis. So we're going to go in increments of 1 to 9 since the lowest number is 1 and the highest number is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then for the horizontal axis, it's the number of drinks. So in this case here, we can start here at 0, go to 9, and then we can go in increments of 2. So this goes from 9 to 11 because these are all the lower limits. 9, 11, 13, 15, 17, 19, 21, and 23. So when we use our histogram, we know that from 9 to 11 we had 1. And between 11 and 12 we had 3. Between 13 and 14 we had 5. Between 15 and 16 we had 9. Between 17 and 18 we had 4. Between 19 and 20 we had 1. And between 21 and 22 we also had 1. So there's our histogram. Next, pulling our histogram over to this page, we want to describe the shape of the distribution. Well, if we draw a bell curve here, we will notice that it's unimodal and it's symmetric, which means that it's bell-shaped. Now what we want to do is we want to compute the mean and the standard deviation using one varstats in your calculator. So let's go ahead and do that. So we're going to go ahead and put these values into the calculator. First thing we're going to do is we're going to clear our list. Second, memory. Hit number 4 to clear all lists. Then we're going to go to stat and then hit edit and go to L1 and we're going to put in our numbers. So 9, 11, 12. So all the numbers now have been tabulated into L1. We're going to go ahead and get to the screen. So we're going to hit second quit. And then we're going to go to one variable stats. So let's go ahead and do that. So stat, calculate, and then we'll go to one variable stats. And we want list 1. So there's L1. So now we have our stats. So we can find out what our mean and standard deviation is going to be. So if we take a look here, we can see that the mean X bar is 15, which is 15 drinks. And the standard deviation is rounded to 2.7. And so therefore there's our standard deviation. Next, what we want to do is we want to be able to compute the mean and subtract the standard deviation and then taking the mean and adding standard deviation, meaning that it's one above and below the mean. And then we're going to count how many of the observations are between these two values. So if we take our mean, which is 15, and we subtract 2.7, that gives us 12.3 drinks. Then we take our mean, which is 15, and then add the standard deviation, which is 2.7. So therefore, it's going to be in between 12.3 drinks and 17.7 drinks. So if we take a look at the graph, let's go ahead and take a look at the graph and see how it looks approximately. So it's about 12.3, so it's somewhere around here. And then we have 17.7. So that's somewhere around there. So that means that it's one standard deviation away from the mean. Now, if we take a look at the values, okay, where it says we want to count how many of the observations are between these two values. Well, let's count all the numbers. Well, we know 9, 11, 12, and 12 cannot be included because it's below 12.3. But then we can include everything from 13 to 17. And then we can't include anything further than that because it has to go in between 17 up to 17.7. If we count all these numbers, that means that 16 are within one standard deviation away from the mean. Next, we want to find the percentage of observations that lie within one standard deviation of the mean. So to find the percentage, we're going to take the value of those numbers that are within one standard deviation from the mean, which would be in the numerator, and we're dividing it by the total. So 16 divided by 24 gives us approximately 0.67, which is equal to 67%, which is the percentage of observations that lie within one standard deviation of the mean. Next, what we're going to do is we're going to take the mean and subtract 2 times the standard deviation and add 2 times the standard deviation to the mean. And then we're going to count how many of the observations are between these two values. So we take 15 minus 2 times 2.7 gives us 9.6 drinks. And 15 plus 2 times 2.7 gives us 20.4 drinks. So if we count all the numbers that are in between 9.6 and 20.4, well, 9 is lower than that number, so we can't include that. And 21 is above this number, so we cannot include that number. So that means all of these numbers between 11 to 19 are within 2 standard deviations away from the mean. Now, what can we say then about the values 9 and 21? Well, since they are outside of 2 standard deviations away from the mean, then we're going to call 9 and 21 unusual numbers. Next, we're going to find the percentage of the observations that lie within 2 standard deviations of the mean. So we know there's 22 of them, and we're going to divide it by the total of 24, which gives approximately 0.92, which is equal to 92% of observations that lie within 2 standard deviations of the mean. In part H, now we're going to take the mean and subtract 3 times the standard deviation and add 3 times the standard deviation to the mean. So if we take 15 minus 3 times 2.7, that gives us 6.9 drinks. 15 plus 3 times 2.7 gives us 23.1 drinks. So that means that all of these numbers between 9 and 21 are going to fall within those, which means that we have all 24. So if we want to find the percentage of observations that lie within 3 standard deviations of the mean, 24 divided by 24 is 1, which therefore would equal 100%. Now, because of the shape of the distribution, we can apply the empirical rule. Are the results you found in parts E, G, and I agreeing with the empirical rule? We can say yes.